Hello there, fellow data analysts. On the topic of univariate analysis, today I will briefly uh, demonstrate measures of dispersion or variability in the statistics. And the two models of statistical analysis for dispersion or variability that I will cover are range and standard deviation. So let me go to the paintbrush canvas where I drew some illustration, for example, of today's lecture. So the first one is range. Range is one of the statistical methods to look at dispersion or variability in the distribution, and it's simply the largest data value minus this smallest data value minus the largest data value. So, for instance, if we have a sample of or a variable of data going from 2 to 10, where 2 is the lowest and 10 is the highest, range will be 10 minus 2 and 8. So 8 will be the range number for this variable. Next thing is the deviation and variance. So pay attention to this part because it's very, very important, especially in understanding standard deviations. It's important to know the building blocks, and deviation and variance are building blocks and the precursors to understanding standard deviation. So deviation is nothing but the distance of each value point in the distribution from the mean. So let's say that we have data point here that's 195, and we had an average of 160, which is this number 160, and so the deviation would be 35, which is the difference between the average and the data point. Let's say we would like to look at 100, so 160 is the average, and 100 is it this data point, so their deviation will be 60. So so deviation is again nothing but the difference or the distance between a value and its average. Remember that if your deviation is on the right side, on the right spectrum of your distribution distribution, that we call that deviation a positive deviation, and if it's on the negative spectrum of your distribution, that we call that negative deviation. And remember, the sum of all the deviations equal to 0 because that's the average. And remember that if all our data is only one data, let's say if all the data points were 160, then we would have a standard deviation or a deviation of 0 because there is no value points, there's no data points to actually measure the average from. In that topic, squared deviation again. So sometimes the differences could be minus if it's on the left, or it could be positive. Sometimes, let's say, for example, this number here is actually minus 6. So this number here is 100, and the deviation is 100. The average is 160. So this number is 60 below the average. Or this number is 195, and the average is 160. So this number is 35 value points above the average. So squared deviation allows us to actually standardize those deviations, those differences in absolute number. So squaring a deviation or squaring any number would actually give us an absolute positive value, regardless of that number is negative number or positive number. So the sum of squared deviation is pretty much the sum of each of these the difference from each of these data points with their average. So it's important to understand, but it's important to understand this, at least this terminology or this term or this sum of squares, because sum of squares leads to what we call variance. So variance is nothing but the sum of the sum of deviation squared, meaning even if it's negative, if it's positive, so all of them become a square, which become absolute number or positive number, and that's divided by the n minus 1, which is then total number of samples minus 1. And if you're dealing with statistics number, remember that n will always be minus 1. So whatever number of samples there are in this distribution, that will be minus 1. So, and then you get the variance, and variance is the average of squared deviation. It's the average of deviation. It's the average of differences of all these data points from their mean, from their average. So the numbers that you really report, that you really analyze in the statistical data analysis, is of course range and variance. The square deviation and sum of square deviation or sum of squares, these are the building blocks. These are the foundations. These are the ingredients that lead you to variance. But I still wanted to cover them so that you have an understanding what they are. And this is the formula for variance, and the variance, the symbol for variance is S2. Let's now go to standard deviation because again, it's a building block. And now once we get this variance, we use the variance, which again is the sum of square of each of data points minus the average, and we square them and we put them under a square root, and then n minus 1. So pretty much this formula, this variance that you get, for example, if you get a variance of let's say 10 from this distribution, then you simply put that 10 under square root, and that will give you your standard deviation. So standard deviation is the square root of your variance. And again, standard deviation is nothing but an average or standardized distance of your observation of your data points or values from their average. When you standardize those differences we just talked about, when you standardize these differences in terms of standards, then that's your standard deviation. And the formula again is to simply put your variance under a square root, and that will give you your standard deviation. And the symbol for standard deviation is S, while the symbol for variance was S2. Now let me go to the next paintbrush canvas where I exemplified this in the context empirical rule. So to understand the standard deviation, it's really important to understand empirical rule, because empirical rule actually deals is the structure of standard deviation. So we use standard deviation in the context of empirical rule when our distribution is approximately normal. This is a perfectly normal distribution, but approximately normal distribution would also be something close to this. So if your distribution is not bell curve and approximately normal, then do not use the empirical rule to measure your variation or variability in your distribution. So let's look at this distribution here where we have a low number. We have a distribution of numbers starting from 85 to 105 or 6 maybe, and we have a mean or average calculated at 100 and a standard deviation that's calculated as 5. So each standard deviation, and we have 3 standard deviations to the right, 3 standard deviations to the left. So each standard deviation score is 5. So in order to standardize these different observations, or this difference in observation, we use the score of standard deviation and multiply it by the standard that's out there. So for example, one standard deviation would be 5 plus 100. 2 standard deviation would give us 105. 2 standard deviation would be 100 plus 2 standard deviation, which is 10, 110. And then 3 standard deviation will be 15, because 3 standard deviation is 15, and that will be plus your average 115. Same thing goes with a negative standard deviation. So if you get a negative standard deviation, that will be, if a standard deviation is 5, then you go 5 numbers backward. What does that exactly tell us? I know it can get a little bit confusing. Trust me, when I started college back in the days and I was starting to learn statistics, this did not make sense to me until I put this into perspective and use, very tangible examples to make myself understand. So standard deviation here, to understand standard deviation, you have to look at the empirical rules distribution. So the empirical rules distribution says that 68% of your distribution falls within -1 and 1 standard deviation. So and then 95% of your observation falls within -2 standard deviation and 2 standard deviation, and 99.99%, approximately all of the remaining, nearly all observations falls within 3 standard deviation, and in which case that will be 85 to 105. So standard deviation in this case allows you to analyze and report proportion or the measures of your distribution, where they are located, where you can measure between two values and say how many percent of those values are contained between each other, or where those values fall in terms of percentages, in terms of distribution. And honestly, it has a lot of use in statistics, and especially in inferential statistics, in predictive analytics, where you don't have population data, but you use standard deviation to infer about standardized differences from the average from a distribution. And let's really quickly look at the properties of standard deviation. The greater your standard deviation score is, the higher it represents, the more variability it represents in your distribution. And just like variance, it's when all observations take on the same value, then your standard deviation is 0. And it makes sense, because if there's no observation to compare your average from, then of course your standard deviation and variance will always be 0. And lastly, remember that outliers have huge impact on your distribution. So if you have outlier and you're using empirical rule, then of course outliers skews the symmetry of your distribution. So if you have outliers, then you can't call your distribution a normal distribution anymore. So remember, if you have significantly skewness in your distribution, then maybe using the empirical rule and standard deviation in the method of empirical rule may not be the right choice of statistical analysis. And just lastly, remember that this is the chart. Again, 68% of observation falls within -1 and +1 standard deviation of difference from the average, and 68% and 95% of observations fall within -2 standard deviation and +2 standard deviation, and 99.99% of your observation falls within -3 standard deviation and +3 standard deviation. And this is called the empirical rule. Let's go to SPSS so I can illustrate how to attain range and standard deviation. So I have a variable here, life expectancy. It's not real data; it's just dummy data. I just punched in a series of values in here for the sake of this training. So I would like to conduct a analysis to explore dispersion of this variable. So simply I go to Analyze toolbar and then Descriptive Statistics. And there are two ways I can do that. I can either do it through Descriptive command or Explore command. So Descriptive command, the variable is already there, so just drag and drop the variable onto this box, click on Option, and then you select your descriptive statistics that you'd like to use for your analysis. So I would say standard deviation, variance, and range. These are the three things you would like. And then click on OK, and then click on OK again. There you go. You got the result. Another way to do it is through, again, descriptive statistics, Explore, and I already have it there because I was preparing for this video. So simply put your variable on the dependent box, and then click on statistics, and make sure you have the descriptives checkbox on. Click on continue, and then click on OK, and you will get your result here. So this data set, which I populated this, or artificial data set, actually has an average of 66. So the average or life expectancy average is 66 years old, and the standard deviation is 13. So, and I also checked the normality of the distribution. It's a normal distribution. So now you can use the standard deviation of 13 to actually standardize and also measure the variability and dispersion of other data points and their differences from the average, in which case is the average of or life expectancy average, using the empirical rule which I explained earlier. So with all that being said, I think there's nothing else left to cover. I hope that this video could teach you some stuff about standard deviation. Although I understand it's a very complex topic, I promise I'll have additional videos where I can provide additional explanation using examples and practices. Thank you for your time.